8th graders, today's lesson is 1.6 Force in Motion. Hopefully, if you guys are working on this from home, you are going to watch this video clear through to the end, as this assignment is part of a test grade for you guys today based on how well you guys do with the modeling activities, which I'll explain here in a little bit. Before we get to those, though, we're going to go over our warm-up, which is a little bit lengthier than normal today. As I want you guys to talk about our little asteroid collection mission pod, what normally happens, and then see how we can use this, the sim to support our answers there. Okay, your overall focus of today's lesson is to model how different strength forces can cause different changes in velocity. So you guys, this is very much similar to what you guys did in 1.5, except you guys are going to show me specifically what happens to our asteroid collection mission pod. So let's go ahead and move on to slide 2. Okay, if you guys remember, in most normal ACM missions or asteroid collection missions, okay, the pod is moving to the right at a medium speed. Then it has these little thrusters on it that deliver a force to the left. So they fire and put a force to the left of a medium force on the pod, and that causes the pod to slow down and stop. Okay, and then once it's stopped, it can dock with the space station and deliver its little asteroid collection samples that it collected. Okay, that's normally what happens. So we're going to go ahead and use the sim to demonstrate the normal ACM pods. Okay, so normally this is how the ACM pod docks with the space station. Let's see what that would look like in the sim. So you guys are going to open your sim link up. Okay, remember your sim link looks a little bit something like this. And what we're going to use is, as we've seen so far in the models, is we've seen small, medium, and large velocities, or slow, medium, and fast, if you will. We're going to use the same kind of thing, but we're going to do it as a value for our velocity. So the ACM pod was traveling at a medium velocity, so we're going to set our horizontal velocity of the A puck to 2 meters per second to the right. So 2 would be what we would use to represent our medium velocity. Okay, 1 would obviously be our slow velocity, and 3 is going to be our fast velocity. So we're going to kind of stay within that range of 1, 2, or 3 centimeters per second. Okay, again, most ACM pods are moving to the right 2 centimeters per second. Okay, we're going to go ahead and press run, and we're going to see the force that the thrusters actually put on it and what that does to the pod. So we're going to hit run, and then we're going to go ahead and hit prepare force. We're going to prepare the force that the thrusters are going to put on that pod to get it to stop. Okay, so if you guys remember, kind of similar to what we did in 1.5 with the targets, your goal is to get this little asteroid collection mission pod to stop so it can dock with the space station. So we're going to want to apply a force. The thrusters apply a force in the opposite direction. So we're going to do a left force. And then because it is moving 2 centimeters per second to the right, we're going to apply a force of 2 clicks, or in this case 20 newtons to the left. So once we hit exert force, we should see that that stops our little pod or our little puck, and that would allow that pod to dock with the space station. So if we were to run that through and analyze again, we have our asteroid collection mission pod moving to the right. At a medium speed, we apply a medium force, and that stops our little pod and allows it to dock. Okay, so that's what should happen each time this little ACM pod collects samples and then wants to dock with the space station to deliver the samples. Okay, let's take a look at some different hypotheticals then. What happened to the normal pod in the sim after you exerted the force? So if we look back at this again, here's about where we exerted our force. Okay, so what happens after? Okay, what happened to our pod? Okay, what would you think would happen to the pod if we would have put a force of 3 clicks, which is 30 newtons, a force to the left instead of just 2? If you guys aren't sure, go check it out in the sim. Go rebuild, set your speed at 2, go add 3 clicks of force to the left, and see what happens. Okay, if you're not sure. Next slide, what do you think would happen if we would have only put a force of 1 click, which is 10 newtons of force to the left instead of 2? Again, if you're not sure, just do it where you have 1 click of force, okay, or 10 newtons, and see what happens to your little ACM pod. Unfortunately, the pod did not dock with the space station. What happened to the pod? So as you guys remember, what actually happened to the pod? Remember, we had the videos cut out. We weren't really sure exactly what happened, but we saw the pod have a change in velocity. What was that change in velocity? Okay, if you guys need to, go to slide 6 to refresh your brain. So normally when the thrusters fire, the pod will stop, but this mission was different. So the pod approached the space station moving to the right at a medium speed. Normally the thrusters fire to stop the pod, but in this case, we kind of had our video cut out, and all we saw was that the pod turned around and started moving to the left. So there's two options here. Either the thrusters caused the pod to move in the opposite direction, so instead of stopping it, it just changed its directions and moved away to the left, or it didn't stop the pod, it only slowed it down, the pod kept moving, collided with the space station, which we haven't talked about collisions yet, okay? But basically what happens is our thrusters fired and it didn't stop the pod, it only slowed it down. So it kept moving to the right, eventually it hit the space station and then bounced off and moved to the left. Okay, so we're kind of talking what happened prior to the collision with the space station. So keep that in mind. We're not talking about what happens when it hits the space station. We're going to talk about what happens right before. Okay, so the two claims is the thrusters caused the pod to move in the opposite direction, or the thrusters only slowed the pod down. It didn't stop it. Eventually what happened is the pod hit the space station, which made it bounce and move in the opposite direction. So just focus on the beginning part of that, and that the thrusters only slowed the pod. It didn't actually stop it. Okay, so answer these two questions for your warm-up as well. If the pod went in the opposite direction because of the thrusters would have exerted blank, so either circle a force greater than, a force less than, or a force equal to the usual thruster force from other missions. Okay, and with claim 2, where it just kept moving towards the space station and eventually hit it, if the pod crashed into the space station because of the thrusters would have exerted a force greater than, a force less than, or a force equal to the usual thruster force from other missions. So either one of these are possibilities as to why our pod moved in the opposite direction. So how would the force be different from the thrusters in each of those? Is basically what you guys are answering. Okay, once you guys are done with that, you guys can come back to this video. We're going to review 1.5's modeling tool and how different forces cause different changes of velocity, and then we'll move on to the assessment. So go ahead, take a second, pause this video, finish up your warm-ups through slide 8, and then we'll come back. All right, so yesterday you guys should have completed this 1.5 modeling tool. Okay, I'm going to go ahead and open that up for you guys. It looks a little something like this, where the only thing you guys had to do is grab one of these arrows and show me what different forces would have occurred to cause these changes in velocity. Okay, so the first one, we can see that our pod was moving at a medium velocity to the right, just like the normal ACM pods. And in this case, it slowed down. So what would that force look like? Okay, in this case, we're moving medium velocity to the right, but we exerted a force and this puck stopped. Okay, the last example is moving medium to the right, and in this case, it turned around and went the opposite direction. So you guys would just designate the proper direction and size of the arrow to show what force would have caused these changes in velocity to happen. Okay, if you guys did not do this from yesterday, I want you guys to pause this video now. Take a second, go in and do this modeling tool really quick. You'll need it to finish 1.5 anyway, so if you guys do it, it should save and be available for you guys to finish up slide 13 on 1.5. But at any rate, I want you guys to have this done before I go through it with you guys, so pause this video, take a second to complete this modeling tool. All right, welcome back. You guys should have assigned an arrow to show me which force caused each of these three changes. So all three of our little pucks were moving to the right at a medium speed. I'm going to go ahead and actually start out of order and do this second puck. So we know it's moving to the right with a medium speed. We applied some force to it, and that puck stopped moving. So anytime we want an object to stop, we have to apply a force in the opposite direction of its movement. So it was moving to the right, so we need a force to the left to get it to stop. Our options are small, medium, or large. Because we are moving at a medium velocity, just like in the sim you guys would see, we need to exert a medium force to get it to stop. Okay, so that would cause our pod to stop. From there, we can kind of use that as a guide to help us figure out our other two. So this one, we have it moving to the right with a medium medium velocity. And in this case, we apply a force that only slows the pod down. So first of all, which direction would you have to exert this force? Okay, if you said to the left, that's correct, because you want to move in the opposite direction. So, and then we look and we know a medium force would stop a medium velocity. We're only slowing ours down, so that means we must have added a smaller force than what our velocity was. So we would put a small force on that one. Okay, that would cause our puck to only slow down but not stop. Okay, and then finally we have the medium velocity puck. That's going to turn around and move the opposite direction. So we know we would have to put a large force to the opposite direction. So those three forces will cause these three changes in motion. And that should be a good review for you guys going into our test. Okay? All right, let's take a look at our actual assessment. Okay, so just as a reminder, you guys have seen this before already several times. We have two reasons that our pod moved in the opposite direction. And basically what you guys are focusing on today is one object prior to any collision, okay, what happens with the thrusters and the force that the thrusters put on that pod to cause one of two things, okay? In claim 1, we said that the thrusters cause the pod to move in the opposite direction. So you guys have to think, all right, if it's moving a medium speed to the right, what force would those thrusters have to put on that pod to get it to turn around and move in the other direction? Okay, for claim 2, the thrusters only slowed the pod down. It didn't stop it. Okay, that's the part you guys are focusing on. I really don't want you guys to focus on the collision yet. Okay, we know it eventually will hit the space station and collide and move in the opposite direction, but for right now, we're just modeling the force of the thrusters that would cause it to only slow down, not stop, and keep moving till it eventually hit the space station. So again, you guys are just modeling the thruster force in these two activities. Okay, we're gonna take these one at a time, and you guys can pause as you guys go. The first one up is claim 1. You guys are gonna have a different modeling tool. Okay, so we're gonna go ahead, open up this link here. Hopefully it opens quick. The last one took a long time for me to load. Okay, if at any point you guys need, you guys can use the sim to kind of help check your answers. So use that 1, 2, or 3 centimeter per second velocity, and that will help you guys check your answers to see if you guys came up with the right modeling of the force of the thrusters to get that pod to change direction accordingly. Okay, so claim 1, open the force and motion modeling tool activity. When your model is complete, press hand in. You guys aren't actually going to hand it in. You guys are going to screenshot it onto the next slide. Your goal is to model the thruster force. Again, you guys are focusing just on the force that the thrusters put on that pod that would cause the pod to move in the opposite direction. Okay, so in claim 1, that pod just turns around and starts moving in the opposite direction. Okay? All right, so what you guys will have is for each of these, you guys have a comparison. This is normally what happens, okay? You don't have to do anything with this top line right here, this top row. So most of the ACM pods come in at a medium speed. The thrusters apply a medium force in the opposite direction, and that causes the pod to stop. But we know that didn't happen. So the first thing you guys will do is you guys will add your pod to both of these screens, okay? In your middle one, during the force, you're going to model the pod, okay? And in the other one, the after the force, you're going to show me the change in velocity that happens with this force, okay? So remember, claim 1 says that model the thruster force that would cause the pod to move in the opposite direction. So our pod's going to be moving in at a medium speed, and then it's going to turn around and move in the opposite direction. So show me that velocity change in the after force, and then in the middle during the force, show me what that force of the thrusters is going to look like to cause that pod to turn around and move in the opposite direction, okay? Some little tips for you guys. Use the first row as a reference. Use the second row to show what happened to the pod. So again, you're not doing anything to this first row. You're only doing the pink arrows in this box and the velocity in this box. Don't forget to add a puck to each, okay? Drag one force arrow into the during force panel so it shows the direction and strength. So make sure you guys have the correct left or right arrow and the strength, okay? Our object is going to turn around and move in the opposite directions with the slow velocity. And then drag the velocity lines into the after force panel so it shows the pod's final velocity. So what happened to that pod, use these little velocity directions and stuff to show what it's moving like after the thrusters exerted their force, okay? Once you guys are done with that, if you need to, you guys can open up this sim and you guys can test it, but what you guys are screenshotting here is the modeling tool. You should have this completed. I want you guys to do this whole box here so I can see your size of your arrows, okay? Screenshot that and then go ahead and put it in on slide 12. Okay, pause this video, give yourself a second to focus just on claim 1, the thruster force that caused the pod to turn around and move in the other direction, okay? Screenshot it on 12 and then come back to this video when you're ready for claim 2. All right, claim 2, you guys are doing a different modeling tool, so you guys will need to open that up as well. Okay, you guys can also use the sim to help you guys check your answer there if you guys want to make sure you guys did it right. So remember with claim 2, you're going to model the thruster force. Again, just show the force of the thrusters that only slowed the pod down and didn't stop it. Okay, you don't have to worry about the collision with the space station yet. We'll talk about that in chapter 3. Right now, you're just working on what that force from the thrusters did to the pod to cause it only to slow down. Okay, so open up the modeling tool. Again, when your model is complete, I don't care if you guys hand it in an amplifier or not, but you guys will screenshot it on the next slide. Same thing that you guys did on the other one. You're gonna need to drag your pucks. Okay, so we're gonna drag puck A. We're gonna drag puck A. Okay, show me your change in velocity that demonstrates claim 2, where the pod turned around and it only slowed down, it didn't stop. Okay, so it was going at a medium speed. What would it look like if it only slowed down and didn't stop? So do that in the after velocity. Remember, this first row is what normally happens, so you guys can use that as a comparison. And then in your middle during force column, you guys are going to do the appropriate size and direction arrow that's going to cause that change in velocity. Okay, so same thing, use the first row as a reference, use the second row to show what happened to the pod. Okay, for claim 2, where it only slowed the pod down. Okay, not any collision. We shouldn't have a second object in there showing a collision yet. Okay, drag one force arrow into the during force panel so it shows the direction and strength of the thruster force, and drag velocity lines into the after force panel so it shows the pod's final velocity. If you guys need to, check your answer in the sim, but you guys are screenshotting this completed model onto the next slide, slide 14. Okay, once you guys are done with that, you guys can move on to the last one. So go ahead, pause, finish up your claim 2 modeling tool, and then let's move on to the last little portion. Okay, so you guys should have finished both of these. This is going to be a little writing option, except we're going to use some little fridge magnet style here. So claim 1, firing the thrusters would have caused the pods to move in the opposite direction if, so you guys are going to tell me about the force of those thrusters using only these words. It's okay if it doesn't grammatically make sense, like if you guys are doing it in past tense, whatever the case is, and that word isn't there, or if it's plural, or whatever the case is, just do the best you guys can. You'll need to be in your cursor. You guys will reach down, and you guys will grab those words that you need. If you need more than one of the same word, but there isn't options down here, you guys can copy and paste as well to grab more. Okay, you're going to do the same thing here for claim 2. Firing the thrusters only slowed the pod, it didn't stop it. The pod hit the space station, which made it bounce and move in the opposite direction. This would happen if, so again, tell me about those thruster forces that would cause it to keep moving but at a slower pace. Okay, once you guys are done forming those explanations using your little fridge magnets, you guys can go ahead and do your wrap up. Do you have any questions? Circle yes or no. If you have questions, type them there, and then 4, 3, 2, 1, how do you think you did? Okay, great job. Go ahead and hand that in, and I hope you guys are having a great day. Bye.